All right, hello, welcome to our lesson for Thursday, September 24th. We're going over arithmetic operations today. And you can see kind of some stuff here. I'll walk you through this as we go, of course, but hopefully you'll need these links at some point during the lesson. All right, so before we get too far into it, I just have a warm-up from variables the other day. So let's see if you can pause the video here and find what's wrong with this code. All right, so the answer to this is when you do this int x, that makes a little bucket on your computer, a spot that holds a value, and it's referenced from the name of x. Okay, so initially when you do that first line, there's 7 in the bucket, but then once you declare it here, this int x, you don't need to do the int part anymore. So if I wanted to update this value of x, I would just say, you don't need the int part, you just say the bucket x is going to be whatever is in the bucket before plus 3 more. So this would now have 10 because we'd add 3 to what was in there before. Okay, so the big thing is you don't need to redeclare it here. You just need to change the bucket x to be 3 more than it was before. All right, and then this will just print out and display a 10 at the end. So common mistake, students want to put int there again, but you only have to do that the first time. All right, I think I put this in here in past years. Students had difficulties with the workspace stuff. When you're loading up Eclipse, it should always point to like the workspace level. So your folder structure should look like this. You should have a workspace and then like chapter 1 programs, chapter 2 programs, and inside of there you'll have a source and bin folder. Source is where most of your .java files will be. SRC stands for source. So that's what it should look like. And when you load up Eclipse, always point it to the workspace level, not one of these sub levels. All right, otherwise it'll start to get messed up. All right, so anyways, add, subtract, multiply, divide, just how do we do them in Java? And this will allow us to do more formulas like, I don't know, find the missing side of a triangle, or calculate the area of some figure or something like that, or convert between dollars and yen, whatever it is, we need these arithmetic operations in order to do that. Okay, if you want to jot down a few things in notes here, I think it'd probably be good to have a few things. These are the different symbols you're going to use on your keyboard. So there's no divide key on a keyboard, so you just use this /. All right, and then one of the ones that's kind of goofy is called mod or remainder. All right, and we'll talk about what that is, but basically if you just want to jot it down here, and what mod means is the remainder after you divide by a specific number. So if we want to actually have some examples on the next page, I think, yeah, we'll go through those. But yeah, just for now, write down that mod remainder is the % symbol. Okay, and then in general, if you do integer division, all right, so integers don't have a decimal part. So if you just type 10 and 2, 7 and 2, or whatever, these will be treated as integers. And so what Java does is, as weird as it seems, it truncates it. Okay, so since integers can't be decimals, it'll take a number, and let's say you get a number like your answer is 3.956 or something. What Java does is, if it's integers, it'll just truncate that back part and just treat this as a 3. Okay, so it doesn't round or anything, it just calls what's called truncate. So if you have 2.0, something like that, if it's treated as an integer in Java, is just going to truncate and be 2. All right, so this 10 divided by 2 is fine, that just comes out evenly to 5, but this is 3.5, and so Java will actually evaluate that to 3. 1 divided by 2 is 0.5, and so Java will actually evaluate that as 0. Right, and again, if you don't want that to happen, use decimals. All right, and so like these statements, the right way to do it with decimals would be you can do 1.0 divided by 2.0, and then Java will treat that as doubles instead of ints. Okay, so you got to be careful with that. This is tested on the AP test generally in some form or another in the test. Okay, so that's called truncating. So division can be kind of tricky. It'll truncate. Right, still properties of math too, where you can't divide by 0. So be careful in your programs. If you get a divide by 0 error, it's going to blow up in your face. Bad news bears. All right, so mod just means remainder. So like if you forgot how this works, I'm taking 5 and I want to divide it by 2 and give the remainder. right? So what we're really doing in this problem is 5 divided by 2, and then what is the remainder? So it's going to be 5. I don't have a divide symbol. Never mind. So 5 divided by 2, and so the remainder would be 1. So essentially, like how many 2's go into 5, right? And there's 2 of them, and then there's 1 left over. Right? So that's how we get to the remainder of 1. So 8 divided by 2, and the remainder of that would be 0, because 2 goes in there 4 times, and there's nothing left over. Okay, 18 mod 13 is going to be how many 13's go in there? There's 1. And then after you have 1 13 in there, there's 1 left over. So that, sorry, not 1, there's 5 left over, right? So 18 mod 13 is going to be 5. All right, so just to see if this made any sense, pause the video and try these 3 examples down here. You can use a calculator if you need. All right, so 6 mod 5 is 5 goes in there once, and then you have 1 left over. So this would be just 1. 4 mod 9, so there's no 9's in 4. And so if you do try and 4 divided by 9, the remainder would just be 4. And then 55 mod 3, man, how many 3's go in there? You could divide like 55, maybe I'll do it here quick. Do 55 divided by 3. So it looks like it goes in there 18 times. And so then there's probably 1 left over. This is 1/3, right? So 18 3's would be 54. So you have 1 left over. So this would be a 1. Right. So last year I remember they asked me like, why on earth would you ever use mod? Like it seems like a weird thing, but it's actually super useful and it comes up in a lot of different ways. So one from my former job, which I'm going to do an example of here. So, and if you want to follow along at all with any of these, you could make your own little class here. So in our Chapter 2 programs, I probably should have it inside of the programs package, but you can just make one called Arithmetic Operations if you want to play around. All right, and so where I've used it before is I was working in my job and we had let's just say 3 servers that handled a bunch of our traffic. So think of Amazon, right? Amazon's got 11 bazillion people going to it every day. And so they have multiple computers that handle all of the requests from people going to their website, right? They don't just have one Amazon computer. That computer would crash in an instant because it couldn't handle all the traffic. So they divided up among the different computers. So at my company, we did the same thing. And the way we did it was we each time they made a new order, there was a new order number. And so we would just do the mod of that number and send it to a different server. Okay, so I could say something like this. So I can make a new variable called mod value and take the order number, mod 3. Okay, so this, when you divide by 3, your only remainders could be 0. If it divides evenly, you could have 1 left over or you could have 2 left over. So at this way, it takes an order number and turns it into a 0, 1, or a 2. All right, and so that way we can evenly balance the different servers. So we could say if this is getting a little ahead because we haven't done if statements yet. Right, but we could say if the remainder was 0, right, then we could say, I'm not going to do it here, but we could have some send to server 1. Okay, and then we could say else if mod value equal 1, send to server, sorry for my poor spelling, send to server 2, and then if it's not one of those 2, then it must be a 2, so we could send to server 3. Okay, so that's a way to, what they call like load balancing, where it can take an order number and then do the mod of it and send it to one of 3 different servers. Okay, and in this code here is getting a little bit ahead because it's using ifs, which is the next chapter. But I guess one thing I would highlight here, since we're kind of talking about arithmetic operations, a single equals assigns whatever is here to whatever variables on the left. Right, so mod value is getting assigned this calculation. All right, and then what double equals is used in ifs to say, is it equal to? if I do this in Java, it'll actually assign 0 to be the mod value, right? So if I want to check if it's equal, you use double equals. Okay, so that's kind of just something to know as you get into the next chapter about conditional statements. Right, so that's an example of where you might use mod. All right, the other operations so far, they kind of work as you expect. So I don't know, we could just do int. If I wanted to calculate the sum of some numbers, right, I could do, maybe these are my test scores. I'm not a particularly great student here, so. Right, so you can just sum up test scores just like that, and sum will take on the value of this calculation. You could do like the int the area of a triangle all at once. You could do area. You could do like, I think we did this in the previous one. You can do like 0.5. Sorry, my computer's freaking out here. Times base times height. And of course, you'd need a base and height variable declared ahead of this. Right? We don't have them. That's why it's complaining. The problem with this code, maybe you could spot it, right? Can anyone see what's the problem with that? Great, and the answer is it should actually be a double, because this could come out as a decimal, so we should probably have a double variable instead of an area, right? But you know, that's just how the operations work. So trying to see if I can come up with another example here. Maybe converting like dollars to yen or something like that. So if I want to do yen, I could take my US dollars and divide it by 4.828 or something like that, and that would get me yen. That's probably not the right conversion at all, but that'd be an example of division. Okay, so then this yen would take on whatever the dollars variable is divided by this. Okay, and again, it's complaining because I don't have dollars declared. So to make it work correctly, I would need to make a dollars variable and give it a value, something like that, right? And then it would convert to yen. Okay, so that's basically how you do arithmetic operations in Java. All right, so I want to make sure we're on the right page here and everything. So try these out quick. All right, not try them out, just think them through, and then see what would the x be at the end of each of these little examples. Pause the video and give it a shot. All right, so the first example would be, let's see, if we add those together, it'd be 38, then minus 8 would be 30. Second example, I believe Java does do PEMDAS correct, so it would multiply these first to get 12, and then add that to 44. Okay, and if you're ever not sure, you can type this in to Eclipse and see that it works. All right, so just to verify, I did type it in here, printed out X, and then hit go, and you can see that it is 56. All right, so it is doing PEMDAS. It is doing multiply before add there. All right, last one's kind of a tricky one, but again, because this is integers, right? They don't have a .0 here, and this is an int x. It's going to do integer division, so it's going to be 1.8, and then it's going to truncate that to 1, right? So that is pretty significant to watch for. All right, I'm kind of low on time here, so I'm going to make a second video for the continue this lesson. Thanks for watching.